right, section 65. Today we're going to be simplifying trig identities. To start with, we're going to do some review of negatives. So the review of negatives comes from when we did section 59, and there was an entire worksheet on negatives. And on this entire worksheet, which you guys completed in your other packet, the packet that looks like this, whenever you have a negative radian, you are always changing the symbol of sine only. Cosine does not change. Sine is the only thing that changes, all right? So you just change the symbol of sine. The reason why they're negative sine is because you're going around the unit circle the reverse direction, all right? And again, this is in section 59. So we're just going to do a little bit of a review as if you guys have never done it before. So find each wrapping function value. So we have pi over 3, all right? The W means that you need an ordered pair. So I'm going to write down 1/2, comma, square root 3 over 2. Whenever you have that negative in front, the only thing that you're doing is changing the value of sine. So it's still 1/2, except for now this is going to become negative square root 3 over 2. So you're just changing the value of sine. Next one, we have the wrapping function, 7 pi over 6. I'm in quadrant number 3, negative, negative. So I've got negative square root 3 over 2, comma, negative 1/2. When you have a negative radian, cosine stays the same. And then you're changing sine to positive 1/2. So that's how the negative works, all right? So you change this whole thing to be positive. The next one, normal, 3 pi over 4, we're in quadrant 2. Normally it's negative square root 2 over 2, comma, positive square root 2 over 2. With the negative, you are going to make sine negative. So we have negative square root 2 over 2, comma, and now that's going to be negative square root 2 over 2. So we change only the value of sine. So again, every single time that you have a negative radian, you're only changing the value of sine. Next page. So this is the fundamental identities, okay? Now what we're going to do today is not number-based. What we're going to be doing is changing all of our trig identities into a single trig identity or a constant. The constant will be either be like 0, 1, 2, something like that. So our fundamental identities, you should already know that tangent is sine over cosine and cotangent is cosine over sine. Now what's a little bit different is that tangent can also be represented as 1 over cotangent. And cotangent can also be represented as 1 over tangent. So that's new. Here's how this ends up working, okay? Here's how this ends up working. So cotangent, so I'm going to keep this 1 over. Cotangent is really cosine over sine. The way that fractions work with division, I keep the numerator and I'm going to flip the denominator. You don't have to write this down. Sine divided by cosine equals tangent. So 1 over cotangent ends up just being tangent. It also works for cotangent being 1 over tangent. So I'm going to change this. So we have 1 divided by tangent is sine over cosine. The way that fractions work, we keep the numerator and we flip the denominator. Cosine divided by sine equals cotangent. So this is just me proving to you that cotangent is the same as 1 over tangent and tangent is the same as 1 over cotangent. Okay, just one extra thing. All right, next. We've got secant, cosecant, cosine, and sine. So cosecant is really just 1 over sine, which we know that already. That's normal. That's what we were just doing. Here's what's different. Sine can also be represented as 1 over cosecant, or cosine being 1 over secant, and secant is 1 over cosine. So you can take the reciprocal, division, it works. Those are just fundamental identities, all right? Normally, we don't really use sine being 1 over cosecant or secant being 1 over cosine being 1 over secant. We normally don't use these middle ones, but just know that you can, okay? So here we go. We're going to simplify each expression into a single trig function or constant. It's going to be one of like 2 or 3 days. You're always going to start by making things into sine and cosine. That's going to be the easiest way to do it. Okay, you're going to make it bigger only to make it more simplified. Trigonometric function. All right, so we've got sine x, secant x. So what I'm going to do is start by changing secant x into 1 over cosine. So here we go. We've got sine x is going to stay exactly the same. I can put sine x over 1 just to make it into a fraction because I'm going to change secant into a fraction. So I put sine x over 1, and I'm going to change this secant to 1 divided by cosine x, which is what it is normally. The way the fraction rules work is when you multiply straight across. So I'm going to change this into one single fraction by multiplying straight across. So sine x times 1 is sine x, and then 1 times cosine is cosine. And now I've got sine divided by cosine, which I can change into tangent. So my final answer for this entire problem is tangent. So I changed something with 2 trig identities into 1 trig identity. So I just made it smaller. So I get a little bit bigger. By number 2, we have cotangent x, and then we've got secant x. So there's 2 things that I have to change. I'm going to have to change cotangent x, and I have to change secant x. So we're changing these into sine and cosines. So cotangent is really cosine divided by sine. So I just changed cotangent into cosine divided by sine. Next, we've got secant. I'm changing secant into 1 over cosine. So it gets a little bit larger, only now I can cancel. I have 1 cosine in the numerator and 1 cosine in the denominator, which means that I can cancel those out. Multiplication rules. So really, we have a 1 in the numerator divided by sine x. 1 divided by sine is always cosecant. So my final answer is cosecant x. All right, number 3, this is division. We're going to start by changing these. So you just have to start by changing these into sines and cosines. I'm going to change that, and I'm going to change this. All right, so I'm going to change cosecant into 1 over sine x divided by, because the division sign that was right here. And then we have secant, which is 1 over cosine. And now this is going to go from division into multiplication. So you're going to keep the numerator, 1 over sine x, and you're going to flip the denominator. So it's going to be times cosine over 1. And now I can multiply straight across. So we've got 1 times cosine, which is cosine x. And then we've got sine times 1, which is sine x. Last thing that we have to do is change cosine divided by sine into cotangent. So your final answer is cotangent. So we went from cosecant x over secant x into your final answer being just cotangent. Number 4. So I've got cotangent x divided by cosecant x. So we've got to change cotangent x, and I've got to change cosecant x. So we're changing both of them. Cotangent is cosine over sine. And then we've got divided by. I'm going to change cosecant into 1 divided by sine. So we start by just changing it into the identities that we know. Then we're going to change our division of fractions into multiplication. You're going to keep the numerator, which is cosine over sine, times, you're going to flip the denominator. Now we're able to cancel. I have something in the numerator and the same thing in the denominator. They cancel out. We're just left with cosine over 1, which is just cosine x. So into the smallest possible thing is what we're changing it into. Let's try number 5. We've got tangent x divided by cotangent x. So we've got two things that we have to change. We have to change tangent and we have to change cotangent. So tangent x, I'm going to change into sine over cosine divided by cotangent. You're going to change into cosine divided by sine. And here we go. We're going to change division into multiplication. So we're going to change sine, well, we keep sine x over cosine x. And then you're going to flip this around. So we're going to have sine x over cosine x. Now I want you to think, when you normally multiply variables, if I were to have x squared, if I have x times x and multiply them, you'd get x squared. Or if you have y times y, it'd be y squared. So now that I have sine times sine, we have sine squared x. And notice where I put the exponent of 2. It's on the sign, not x. All right, we are not multiplying variables. We're multiplying trig identities. So sine times sine is sine squared divided by cosine times cosine is going to be cosine squared. Normally, sine over cosine is tangent. Now that we have sine squared over cosine squared, this is just going to be tangent squared. Next, we've got three things. I've got secant x times sine x over tangent x. So I'm going to change the secant x and I'm going to change this tangent x. So I'm going to change secant x into 1 over cosine x. And then we've got sine x divided by, and I can change tangent x into sine x over cosine x. So I'm going to keep that 1 over cosine from the secant, the thing that I have in purple. I'm going to keep that normal. So I have 1 over cosine x times, all right, so now we have sine x divided by sine x cosine x, right? Divided by. So I'm going to keep the numerator, sine x, times, and I'm going to flip the denominator. Now there's this sine x right here that I have in gray. I can really instead put this over the number 1, so now everything is a fraction. Anything that I have in the numerator can be canceled if it's in the denominator. So sine cancels with sine, cosine cancels with cosine, 1 divided by 1 cancels, and we're left with the number 1. In division, the only way that you get 0 is if you have 0 divided by a number. All right, so with division, if you have the same thing on top as the bottom, you get the number 1. So all of these are reducing into one single trig identity. Here we go, the trigonometric cofunction identities. So this is just a review. Anytime that you have a negative, all right, a negative radian, the only thing that you change is sine. All right, anytime that you have a negative radian, the only thing that changes is sine. Cosine stays the same, just like we did at the beginning of the lesson. So now what we're going to do is introduce negative radians. So in number 13, we have a negative radian. So what's going to happen for cotangent, normally cotangent is changing to cosine theta, which just represents a radian, divided by sine theta. Except for, now that there's a negative, you just put a negative sign by sine. So it's cosine theta divided by sine theta. So it moves to the front of the entire thing. And then you're also going to change secant into 1 over cosine theta. Now you have cosine on top and a cosine on the bottom. Those cancel. So now we have 1 over negative sine theta. And 1 over sine is still cosecant, but since there's a negative sign, it's negative cosecant theta. So in number 14, you're going to change these.